Hello everyone, welcome back. In this video we are going to continue exercise 6.2 of triangles. So we have already completed 1 to 5 questions of this exercise. So let's start with question number 6. So question number 6 says a figure is already given to you. You can see in figure A, B and C, they are points on OP. This is point P, OP, OQ and OR such that AB is parallel to PQ and AC it is parallel to PR. AC this is parallel to PR. And we have to show that BC it is parallel to QR. So this is BC. We have to show this BC it is parallel to this QR. So same way we have to start. First of all we'll write what is given to us. So given it is AB, it is parallel to PQ and AC it is parallel to PR. So all the things which are given to you, you can write in given. Then to prove, so what you have to prove? You have to prove that BC it is parallel to QR. Now let's do the proof. So before doing proofs, this figure is already given to you. So we'll do rough sketch. We'll draw a rough sketch. We know it's given to us that AB it is parallel to PQ. And we have to see in which triangle. If you see it is OQP. Or POQ in this triangle. So I have already drawn OPQ and here AB I have drawn one line which is parallel to PQ. It is already given to you. You have to be very careful. See on OP point A is there. See OP. So you have to mark point A on side OP and point B on side OQ. Same way you have to draw this triangle OPR and AC it is parallel to PR. A is point on PO. So same way you have to. So while writing the points or while naming the points, you have to be very careful on which side this point is present. So like this rough sketches I have already drawn. Now let's start. So in triangle POQ, if this AB it is parallel to PQ, so according to basic proportionality theorem, if this side or if this line it is parallel to this side of a triangle, then it will divide the other two sides of the triangle in the same ratio according to basic proportionality theorem. So that's what we are going to write now. In triangle POQ it is given to us AB it is parallel to PQ. Therefore OA upon AP it is equals to OB upon BQ. So you can write basic proportionality theorem or Thales theorem because it is known as Thales theorem nowadays. So you can mention the reason also. So if these lines are parallel, then the other two sides of the triangle they are in same ratio according to this theorem. So this we can mark it as point 1. Now let's see another triangle. In triangle POR, it's given to us AC it is parallel to PR. So you can write it is given. Therefore, again according to basic proportionality theorem, if this line it is parallel to this side of the triangle, then other two sides of the triangle they are in same ratio. So we can write OA upon AP it is equal to OC upon CR. So mention the reason basic proportionality theorem or Thales theorem. So you can mention and write it as point number 2. So 2 points are there. Now if you observe carefully, you can see in both of these OA upon AP is present. This is also equal to OA upon AP and this is also equals to OA upon AP. and I have already explained you in the previous questions 1 to 5, because we have already come across this type of situation. So if if two terms they are same to a common term, then they are equal to each other also. Why? Again I will explain you. So if x is equals to 1 and y is also equals to 1, from these two we can see x is equals to y. Same way, if you see that this is your 1 in this case, in this term, so which means if this is equal to this and this is also equal to this, so you can say now from 1 and 2, we can write it over here. This is OB upon BQ. So you can write from 1 and 2, because we have already marked these points. This is as first point and this is as second point. You can write OB upon BQ, it is equal to OC upon CR. You can mention the reason. Terms equal to same terms, they are, or common term, because this is common in both these terms. Terms equal to same terms, they are equal to each other. So these two are equal to each other. So that's what we have written also. Now we don't need these two triangles. And again, if you see the given figure and the thing which we have to prove that BC is parallel to QR. This is BC and this is QR, and you can see this is triangle OQR. OQR is one triangle in which this BC is, B and C points are present on side OQ and OR, and you have to prove this is parallel to this. And if you see these things, you can see OB upon BQ. OB upon BQ, it is equals to OC upon CR. See, now we can use converse of basic proportionality theorem and we can prove that this BC, it is parallel to QR. Because we have already learned in converse of basic proportionality theorem that if two sides of the triangle are in same ratio, then this line BC, it is parallel to QR. So you can write, therefore BC, it is parallel to QR. So you can mention the reason also, converse of basic proportionality theorem. And I have already done the proof of both the theorems. If you have not seen that video, I have shared the link in the description. You can check out. So the second question of this video is 7th question of this exercise, because we are doing questions 6 to 10. So using theorem 6.1, prove that the line drawn to the midpoint of one side of a triangle parallel to another side bisects the third side. So what is given to us? We have to draw one triangle. Let's name it triangle ABC. So they are saying that the line drawn through the midpoint of one side of a triangle. See, let's take point D as the midpoint of side AB. So from this midpoint, they are drawing one line which is parallel to third side of the triangle. So let's mark this point E. So we have to show that this line, it bisects this side also. Bisects means it divides this whole line into two equal parts. Or in other words, we can say E is the midpoint of AC. This thing we have to prove. So same way, each and every question of geometry, try to do in this way. First of all, write the given thing, then what you have to show or prove, then do the proof. And if you are doing any construction, write that construction part also. So given is, if D is the midpoint of AB, then we can write AD is equals to BD. So midpoint means these parts are equal. If anything is exactly in the center, so these things will be equal. So this is already given to us as it is mentioned, it's the midpoint of one side. And DE, it is parallel to BC. This is also given to us. Now what we have to prove? We can write to prove. We have to prove that E is the midpoint of AC, or E bisects AC. E bisects AC means E divides AC into two equal parts, which means AE, it should be equal to EC. This thing we have to prove basically. So let's do the proof now. And if you see this question, here it's mentioned using theorem 6.1. So theorem 6.1 is basic proportionality theorem, or Thales theorem we can say. So we have to use that theorem and we have to show this thing. So let's start. In triangle ABC, it is given to us that DE, it is parallel to BC. If this line is parallel to BC, then directly we can use basic proportionality theorem. So therefore AD upon DB, or BD you can write, it is equals to AE upon EC. So according to basic proportionality theorem, we have already done the proof. If this line is parallel to third side of the triangle, then other two sides, they are in same ratio according to basic proportionality theorem. So that's what I have done here. You can see just the ratios I have written. Now here if you can see, it's already given to us AD, it is equals to BD. So what we will do, here AD is written, so BD and DB both means same thing. So here also you can write BD. See, it is just a name of the line. If you write BD or DB, the line will remain same. So you can write in either way. So just replace BD by AD. Why? Because both of these terms, or both of these lines, they are equal. So here write AD. Just in this step only I am doing, you have to do in next step. So BD I am replacing by AD, because both are equal and it is already given to us. So replace BD by AD. Now this AD and this AD both will get cancelled. So I am left with 1 now. So you can see 1, it is equals to AE upon EC. Now just shift EC to other side. This side you can see AE, it is EC, it is getting divided by AC. So if you change its side, it will get multiplied with 1. So on changing the sides, division will be changed to multiplication. So here EC will be multiplied by this if you change the side. So EC into 1, it will be EC. So EC is equals to AE. You can see that's what we have to prove. Hence proved. What we have done, only we have used theorem 6.1 because it was asked in the question. Now let's do the next question. Next question is 8th question. Using theorem 6.2, prove that line joining the midpoints of any two sides of a triangle is parallel to the third sides. So we have to use theorem 6.2 in this question. Theorem 6.2 is converse of basic proportionality theorem. So let's draw the figure and see which all things are given to us and what we have to prove. So we have triangle ABC. So they have given us the line joining the midpoints of any two sides of a triangle. So this will take these two sides, AB and AC, and D and E, let's assume these are the midpoints of the sides AB and AC. So if we join these two, they are saying the line joining the midpoints of these two sides of a triangle, it is parallel to third side of the triangle. So that's what we have to prove. It is already given to us that D is the midpoint of AB and E, it is the midpoint of AC. It is already given, and we have to prove DE, it is parallel to BC. So given things we have to write first. Given if D is the midpoint of AB, it means AD it is equals to BD. Midpoint means it will divide into two equal parts, and if E is the midpoint of AC, it means AE it is equals to CE or EC you can write. So these things are given to us to show or to prove DE it is parallel to BC. See, we can read the statement again. Line joining the midpoints of any two sides of a triangle is parallel to the third side. Proof. And one thing you have to remember here, you have to use this theorem. Since we have to use the theorem, use theorem 6.2, and theorem 6.2 it tells us if the two sides they are in same ratio, then this line is parallel to this. So we can just assume if AD upon BD it is equals to AE upon CE, then DE it will be parallel to BC according to converse of basic proportionality theorem. So here you can see AD upon BD, it's given AD is equals to BD, AE is equals to EC. So these things are given to us, which means AD and BD, if they are equal, they can get cancelled. Or like in the previous question we have done, you can also replace BD by AD, and here you can also replace AE by CE or CE by AE because both are equal. So just the replacement also you can do. If you don't want directly also you can do, because AE it is equals to CE, so they will also get cancelled. So this side I will get 1, because on cancelling the same terms, if I am cancelling 5 by 5, so I will get 1. So whenever we are cancelling the same terms, we will get 1 as our answer. So this side also the terms are same, because AE it is equals to EC. If you replace also, you can write AE in this way also you can do, or you can directly cancel also. AE upon CE, this way also you can directly cancel, and you can mention as they are equal and it is given to us. So this is also 1. So 1 is equals to 1, which shows us that AD upon BD it is equals to AE upon EC. So because both, this is also 1, this is also 1, so you can write therefore AD upon BD it is equals to AE upon EC. You can mention both equal to 1. You can mention the reason also. See, first of all you have to show this thing. Here also you have to mention it is given to us because they are equal, and then this you have to mention. Now if the sides, now you can say AD upon BD, AE upon EC, that's what we have written. If these sides they are in same ratio, then DE it is parallel to BC according to converse of basic proportionality theorem. So this question was very simple, and if you remember previous question and this question, you have already done these theorems in class 9th also. Midpoint theorem of triangle, one was the midpoint theorem and the other one is, this one is converse of midpoint. So both of these theorems you have already done in class 9th also. Here we just have used basic proportionality theorem and have done these proofs. Now let's do the next question. Let's do question number 9th. ABCD is a trapezium in which AB it is parallel to DC and its diagonals intersect each other at point O. Show that AO upon BO it is equals to CO upon DO. So let's draw the figure first. Trapezium is something like this. It has one pair of parallel sides and one pair non-parallel sides. So it looks like this. It's a quadrilateral which has 4 sides. So ABCD trapezium I have already drawn, which they have mentioned that ABCD is a trapezium, and AB the sides which are parallel to each other, it is AB and DC. So that's what I have written, AB, this is parallel to DC. Now its diagonal, they intersect at point O. See, these are the diagonals, AC and BD, they intersect each other at point O. We have to show this thing. AO upon BO, this is CO upon DO. So here first of all we'll write all the given things same way like we are doing earlier. One construction we have to do in this question. Just draw one line from O to side AD of the trapezium, and this EO, it is parallel to DC and AB. So this is the construction. So you have to mention this also. So start from given, just mention ABCD is a trapezium, parallel sides you have to mention, and diagonals you can mention. So construction is we are drawing one line from O to side AD, and such that this OE, it is parallel to CD or DC you can write, and this OE, it is also parallel to AB. So this is the construction part from our side. We have done, we have drawn OE which is parallel to AB and CD. Now if you see, after this we can start with the proof. To prove this thing we have to show, so you can write that also. And here if you see, so if this parallel line we are taking, first of all two triangles we should take in which this line is present. So here first triangle is this one which I am taking, this one ADB, you can see. So I have drawn ADB, and you can see on AD point E is there, so that's how I have written point E on AD and point O on BD. So I have joined this line. So this EO we have already mentioned, EO it is parallel to AB. Now another triangle which we have to use, because we have to use only the triangle in which this parallel line is there, because we have to use those two theorems in which we have to use lines like this, because previous question also you have seen every figure which we are dealing with seems like this figure. So that's why we have done the construction part here. Now other triangle is this one. In this triangle also you can see EO is present. So this is ADC, and E point is on AD, I have mentioned, O point is on AC. So two rough sketches I have drawn so that easily I can locate all the points and write my results. So let's start now. Why we are doing construction? Because we have to use basic proportionality theorem and it is required for that. So in triangle DAB, or whichever name you can give, EO, it is parallel to AB. So here you have to mention by construction, because by construction it is parallel. OE it is parallel to AB. By construction we have constructed this thing from our side. Therefore DE upon AE, it is equals to DO upon BO. Basic proportionality theorem or Thales theorem. So this is same thing which we are doing in the previous questions also. If this side is parallel to this, if this line is parallel to this, then the other two sides, they are in same ratio. So that's what I have written. So now let's mark this as point number 1. Now in triangle ADC, the second one, OE, it is parallel to DC. Again reason you have to mention by construction. Therefore AE upon DE, it is equals to AO upon CO. So why the sides are in same ratio? According to basic proportionality theorem. We can name it as point number 2. Now if you compare or if you observe points 1 and 2, you can see DE and AE, these are present in both the terms. Here I have DE upon AE, here I have AE upon DE. See the terms, they are in reciprocal form. The term here you can see DE is the numerator and AE is the denominator. Here AE is the numerator and DE is the denominator. So here one thing we will do, because we have to make them same, so we'll just do reciprocal of both the sides. In any of these you can do, so let's do in second. Reciprocal means interchanging numerator and denominator. So that's what we are going to do here. So whenever you are making any change in any equation, you have to make that change on both sides of the equation. I have already explained in first question also, and many other questions wherever we have done this thing, wherever we have made any changes. So both sides of the equation you have to make the same change. So if you are doing reciprocal of this side, you have to do reciprocal of this side also. So if we do reciprocal interchanging of numerator and denominator, so I will get DE upon AE is equals to CO upon AO. So let's mark it point number 3. See, just reciprocal I have done, interchanging of numerator and denominator. So I got DE upon AE is equals to CO upon AO. Now if you observe first and third, you can see I have the same terms now. DE upon AE, here also DE upon AE is equals to DO upon BO, CO upon AO. Same thing, this is present in both. If any terms they are equal to one common term or same term, they are equal to each other. So you can directly write from first and third, not from second, because from here we are getting DO upon BO, it is equals to CO upon AO, because they are both of them, they are equals to DE upon AE. Equal to same term means equal to each other. I have already explained how. In previous question also I have explained you. So from here you got DO upon BO, it is equals to CO upon A. If you see this thing, one last change you have to do, you just have to see what you have to show. You have to show this thing, AO upon BO, it is equals to CO upon DO. But what you have got, DO upon BO is equals to CO upon AO. You need AO and BO on same side. So just do cross multiplication. So from here itself we can do. So same terms, we'll just do cross multiplication, because we need AO and BO on same terms and CO on DO on same side, sorry, not, so we'll do cross multiplication. So this AO, since it is getting multiplied with CO, if you change its side, it will get multiplied. Here it is getting divided, on changing the side it will get multiplied. So write in this way. Here you are left with only CO. Now same thing, just shift this DO, because here we need it, to this side. So here it is getting multiplied, on changing the side it will get divided. So whatever you have to prove, accordingly you have to make changes. See, only interchanging of the terms I have done, and cross multiplication also you can see. So after doing this, we can see we have got the required thing. Now let's do the next question. This is the last question of the exercise, and this question, it is very similar to the previous question we have done. The only thing is that, so it was already given in the previous question that this figure is a trapezium, but here you have to prove that this is a trapezium. So let's read it out what is given to us. the diagonals of a quadrilateral ABCD intersect at point O. So the diagonals of this quadrilateral, they are intersecting at point O, you can see also, such that, so this thing is already given to you, which we have proved in the previous question. Now you have to show that ABCD is a trapezium. So what you have to do, just follow the same things. First of all, you have to do one construction part, OE. This OE, you have to mention it is parallel to AB, and OE, it is parallel to CD by construction. Then same triangles, first of all this triangle you have to use and this triangle. So you have to make the sides proportional, make the sides in same ratio, we can say, and you have to use the converse of basic proportionality theorem and prove that this is parallel to this. See, everything is same triangles you have to use this result. So I want you guys to try this sum yourself, as it is similar to the previous question. And again, if you get any doubts, any confusions, just mention in the comment section. I'll be happy to assist you. So with this, exercise 6.2 is finished, and I am very happy and feeling satisfied to complete this lengthy exercise. So after this, we'll start with exercise 6.3 in the next video, in which we have to deal with different criteria of similar triangles. So thank you so much for watching the video, and if you like and understanding the concept, please mention your comments also, as your comments, they will motivate me. And if you have any feedbacks, any suggestions, please mention it. Thank you so much for watching the video. Have a wonderful day.